All right. So we'll pick up where we left off. We'll be trying to use this dot cam today a little bit. I know it's a little bit clunky, kind of moving back and forward, so we'll have to kind of put up with that. If you ever have any problems kind of seeing it, I was kind of could tell there's a little bit of a glare. I can move it around, so just make sure you let me know you can't see it perfectly. So let's go. Start kind of where we left off last class. So we were talking about the supply and demand curve. We said we can think of the supply curve representing the marginal cost at each quantity, and then the demand curve representing marginal benefit at each quantity, right? So, really what we're trying to understand with the supply and demand curve is what's the relationship between price and quantity supplied, right? That was kind of what our slope was telling us, the relationship between price and quantity supplied, as well as, where were we up here? The relationship between price and the quantity demanded, okay? So the supply and demand curve tell us about this relationship, but you can kind of imagine, I think some of the examples we were working through last class, but think about from the demand side, the very first quantity I may value very highly, the second quantity not as much, so on and so forth. Right? But how much I'm willing to pay isn't just impacted by how much I'm buying, right? Not just the quantity, but it also depends on a lot of other factors. So when we're looking at this demand or supply equation, we're really saying, okay, if we allow the quantity to change, how would that influence the price? Or vice versa, right? But there's a lot of other things that we're holding constant, like the value potentially. I was trying to think of an example today where it won't be one of the main components we talk about, but sometimes there's products where they become a fad, right? And so for a period of time, they may have an over kind of exaggerated worth, right? People are paying more for it than what's actually worth. A lot of the age-old example for that one is like pet rocks. Like at one point, people were paying decent amounts of money to buy a rock, right? Well, that's only because it was a fad at the time. So there's these other things that are factored into how much someone's willing to pay. Okay? So we'll talk about what a lot of these other things are and how changes in them will kind of influence our supply and demand curves. So once again, this should be review from 201, but we'll kind of make sure that we're all kind of getting that revisited in our brain. So first thing we can talk about is demand shifters, right? So we can see a demand decrease. So here, this red line is my original demand curve. If we see a demand decrease for a product, that means that we're kind of getting this new demand curve that's closer to that origin, right? Or closer to that 0, 0 point. So why is that the case? Well, if we see demand for something go down, and we'll talk about all the other, what could cause demand to, shift downward. Think about on the x-axis here, we have quantity. On the y-axis, we have price, okay? So I'll actually draw this out to maybe make this a little bit easier. So let's go to stop share, and I have to go to share, advanced. So there we go. Right. So here we had, here we have quantity, here we have price. So kind of here's our original demand curve. Right? What this is telling us is that, say at this particular quantity, let's just call it 5, just to put a number to it. We were willing to pay kind of, I don't know, we'll say $10 for that 5th unit. Right? What a demand decreases is that no matter what quantity we're looking at, we see that at that quantity, well, if there's lower demand for it, that means people are willing to pay less for it. So they'd no longer be willing to pay $10. They might only pay, I don't know, we'll just make a number up here, 8 now. And over here, for maybe that 6th unit, before they were willing to pay 8, now they're only willing to pay, this isn't going to be completely drawn to scale, but now they'll only pay 6. And that would occur at every single quantity until we get this new demand curve. Let me see here. That'll look something like that, right? Where we see this kind of shift downward, this decrease in demand. Is this like really hard to see for you guys? Is it pretty bad? It keeps on adjusting, doesn't it? Here, let's see if I can get it to stop adjusting. Is that still pretty, yeah? Let me see. Still pretty bad, huh? I'll zoom in, does that help? Is autofocusing better? Not really, is it? Okay, so I don't think this would help, but let's see if this does. Makes it even worse. Let's see. Is that? What caused that to change? All right, well, why would it be getting too much light here? Still isn't really showing up, is it? All right, well, maybe we'll let the, think, why would I, there's a way I can, a brief pause here. Where is it? I know there's settings.
On the Elmo that you can change?
Yeah, so it just has the light and the zoom feature, I think. I'm trying to remember where this is on Zoom. I might have to go into my settings another time. Under here, maybe? 1 second, I think. Just for low light. It's not with, it's actually not with Zoom because it's not showing up on the projector, right? Well, I might have to play around with this another time. If I go through, try it one more time here.
The lens part itself?
Yeah, this part doesn't move for me. I think that there's an, I think there might be an attachment that you can put on there. Try one more thing. This doesn't do anything. I've used this before, but. All right, try one more thing here. That's not what I want. I think I have to go to devices. All right, I guess we'll do this another time. Kind of get an idea from, I'll use what I don't like, which is, we use this annotate. I don't really like this, but I thought that I had this working the other day, so hopefully we can get this to work with this element, but that's typically what I'll kind of switch to where I can draw stuff so you can see it. So hopefully I get the kind of lighting on it figured out for next week. But you can kind of imagine what we were doing there is we're kind of putting numbers to that original demand curve, and what we're just saying is, look, at any given quantity, right, there was an old price that we were willing to pay before. Now, with the demand decrease for that same quantity, I'm not willing to pay as much, right? So we had a lower kind of price down here. And that occurred at every single quantity until we got this new kind of blue curve, right? So the same thing would apply for thinking about demand increases. It's just in the exact opposite direction, right? If we see an increase in demand, then at every single quantity, right? So we've got our old demand curve being this red line. If there's an increase at every single quantity, now the price someone's willing to pay is going to be higher, right? And so we have this kind of new demand curve. So anything that changes other than the price of that good is going to shift our demand curve, okay? So what are some of these things that can cause decreases and increases in demand, right? So the first one we can think about is just more buyers, right? If we think about, I think the way I was kind of discussing it last class, even the demand curve for one individual, right? If, say, one individual would buy 3 units of a product when it costs $10, well, if there's now 2 individuals, each one kind of be willing to pay $10 for 3 units. But if there's 2 people, now at $10, I'll be able to sell 6 units, right? Each buying 3. And if I add another person, now I'll be able to sell 9 units at that same price. So as we add more buyers, even if we hold that price constant, now at that same price, so here's our price, right? At that same price, if instead of 1 consumer, I now have 2 consumers, at that same price, I can sell a higher quantity, right? So adding more buyers is going to increase our demand curve at any price, right? No matter what the price is, there are now just more people willing to pay that price to buy the product, right? So, oops. So to clear this real quick. So now at every given price, I have more people. So a higher number of buyers leads to an increase in the demand curve. Every time I go through these, if I fail to mention the exact opposite change, hopefully you can kind of figure out it would be the exact opposite effect, right? So if I have more buyers, increase in demand. If I have fewer buyers, I'd see a decrease in demand, right? At any given price, there's just fewer people willing to buy it if we see a decrease in the number of buyers. So one thing that we'll get to by the end of the class today is the ticket market. So in the ticket market, we can start to think about how changes in all these factors would influence the ticket market. So let's say I have a city that has a higher population, right? They see an increase in their population. Well, that means if we're looking at the demand for tickets, no matter what sport we're talking about, if there's just more people, a higher population, we would expect to see that demand curve increase or kind of push out to the right, okay? Income changes, another thing that we can talk about. If we think about the average income in a city, let's say it's only, $20,000, right? Well, if I charged, $100 for an NFL ticket in that city, it's probably not going to be that many people that are, going to be willing to purchase that ticket given what their current income is. Now, even if I keep that price constant at $100, if the city's average income then increases to $100,000, well, now there's more people with disposable income. Now they might be more willing to pay that same $100 for a ticket. So anytime we see increases in income, we should think about that as there'll be increases in demand for a product as well. Now that's for most products, right? What I just described, do you remember when we have income changes, what are the 2 types of goods? Anyone remember this? So we've got normal goods, which is what I just described. There's also, if you have the slides pulled up, right, inferior goods, right? So normal goods work how we typically think. If I have more money, I'm going to be able to, willing at the same price to buy more of that product, right? Because I just have more money laying around now. However, right, there are some things that are inferior goods, which work in the exact opposite way. If I have more money, I actually buy fewer inferior goods. Right, the classic econ example that most professors use, or at least I like to use it, is something like packets of ramen noodles. Right, when I'm a college student, I'm making like no money every year. I purchase a lot of ramen noodles, even if the price doesn't change. If I now all of a sudden have a whole bunch more money, I'm now making $100,000 a year. I'm way less likely to buy ramen noodles. Right, or I always use Natty Light, right? Like I haven't bought Natty Light since I was in college, right? Because I now have money where I can buy a little bit better tasting beers, right? In terms of sports, the way that we will probably think about, if we'll encounter any inferior goods, more likely than not, we're thinking about these as like small leagues, right? When we think about kind of our major league sports, we typically, if we think about the ticket market there, it's a normal good, right? We see areas that have higher incomes. We typically see that there's a higher demand for tickets. Now, if we're thinking about things like minor leagues, right? Those might be, if I have more money, I start to attend more NFL, NBA games as I do, these smaller leagues. So sometimes for these less popular leagues or these minor leagues, we can see them kind of work as an inferior good. When people have a higher income, they actually decrease the demand for that product, right? So this is a little bit, something that sometimes we might have a question about whether or not a product is actually a normal or an inferior good. I'm giving minor league tickets as an example. To be completely honest, I haven't seen anyone write a paper to really investigate whether or not they are. So this could actually be a potential question if we could get our hands on some data of, the quantity of tickets sold, what the prices were, and then kind of average incomes in the area for different minor league teams to see whether or not this in fact is a normal or inferior good. But it is an example where you can imagine it potentially could be inferior. Maybe not specific to minor leagues in baseball, but maybe minor leagues in some of these other sports could be inferior goods. Any questions on any of that before we keep going? Like I said, I was wanting to draw a little bit more here with some of these, but I think we'll get to it. I'll use this annotate tool, even though I don't really like it on Zoom. Some of the other things that we can see influencing the demand curve are whether or not we see changes in the prices of substitute or complementary goods. So with substitute goods, these are goods that are used in place of each other. All right, so as the price of a substitute good goes up, is that how I wrote? Yeah, as the price of a substitute good goes up, right, the demand for whatever it's a substitute for will also go up, right? So why would that be the case? Well, you think about it, if there are perfect substitutes, I can buy either one of them and it's literally the same product. Then, for example, you think about with cars, as you see, what would I kind of compare this? So as you see the price of electric cars start to fall, you see a lot more people buying fewer gas-powered cars and more people buying kind of those electric. So the change in the price of electric cars is the price of electric cars goes down. That means they're kind of relatively more, or relatively cheaper and more attractive. So people stop buying or they decrease the demand for gas-powered cars, right? Another example, if in sport, we can kind of think about if you're just wanting to attend a college football game and you just want to see your team play, then potentially even games not on the same day, we might have some substitutability. So, I went to Purdue and kind of anecdotally witnessed this firsthand in terms of a really good example for substitutes. So when you look at the price of Ohio State football games, tickets, they're pretty high and they're hard to get, right? They're pretty scarce, right? And the price is relatively high. The price to attend a game at Purdue University for football is relatively low, right? There's not a ton of people dying to get in there usually in most seasons. So what you would see is when Ohio State plays Purdue, right? Now the price of attendance for an Ohio State fan is much lower than if they were to attend it in Ohio State, right? If they go to travel over to Purdue at Lafayette, they can now pay a much lower price. And so that decrease in the price of Purdue football tickets leads to maybe a decrease in the demand for Ohio State football tickets because they can now go and attend this game, even though it's at a different location, for a much lower price, right? So there's, a lot of times we can think about different games are really substitutes. And it may not even have to be the same type of game, right? We can think about there's definitely going to be some substitutability across leagues, right? Especially people who are just maybe in general fans of any sport, if they truly, viewed every sport the same, right? Within, say, Chicago, right? If you have multiple leagues having games going on at the same time, then potentially changes in, Chicago Bears tickets, the price of Chicago Bears tickets could influence the demand for Chicago Bulls or the Chicago Cubs at the end of the season, right? So there could be substitutability kind of across leagues as well, right? So the idea here being, if I'm going to kind of put a nice little summary in this since I would have had to drawn this out earlier, you can think about, that's not what I wanted to do. That's a text box here. So if I've got, say the price for price of Purdue tickets goes up, and if you kind of think about that would cause the demand, to also go up, right? The price of Purdue tickets goes up and they are substitutes, well, now they're relatively more expensive. I'll switch over and start to buy out more Ohio State tickets or games that are at Ohio State, right? And it would work the exact opposite as well, right? If we see price decreases, and that would lead to, price decreases in the substitute good would lead to demand decreases in whatever good we're looking at. Okay? And we have to be a little bit careful here because when we start talking about now, we're talking about the price change of other goods. What if I'm thinking about the demand for Ohio State football tickets? What happens if the price of Ohio State football tickets goes up or down? Do I see an increase in demand, decrease in demand, or something else? If I see a change in the price of Ohio State football tickets, the demand for Ohio State football tickets does what? If I go back here, does demand increase, does it decrease, or do something else? Well, remember, we said what shifts demand or changes in these other factors, right? But demand is still trying to get at the relationship between the price and the quantity demanded for whatever that particular product is. So if I'm thinking about the demand for Ohio State football tickets, changes in the price of the Ohio State football ticket doesn't shift demand, it just moves me to a different point along that demand curve, okay? So changes in the price of the product you're interested in just kind of move you along that demand curve. They don't cause shifts. The only thing that shifts the demand curve are things other than the price of that good that are changing. So if it's the price of a substitute good that's changing, that's something else, right? That's something not the price of that specific good. And so that's why we think of changes in the price of substitutes would influence the demand of this other product, right? And we kind of talked about those are the two different changes we could see there in substitute goods and an example. So complementary goods work in the kind of, I won't say opposite, but kind of the opposite way of substitutes, right? Complementary goods are goods that I have to use at the same time, okay? You know, a lot of times in a general econ class, I describe this as anything that requires batteries, right? In fact, I'll give you a good car example. I was looking at buying a car last semester, and I was looking at some of these hybrid cars, and you look at the battery replacement costs, and sometimes they're like $1,500 for a new battery. So you're thinking, if I have to, you know, in order to drive this car, I have to also have this battery. Well, if the price of those batteries is relatively high, I may be less likely to demand one of these hybrid cars, right? So if the good I need, right, the batteries that I need to use this good, the electric car, the price of those batteries goes up, well, now it's like the price of using that and owning the electric car has also gone up, right? And so increases in that complementary good actually decrease the demand for whatever good we're looking at, right? Increase in the price of batteries would decrease the demand in overall electric cars. Okay? Another example in sport that kind of is good for us here, you know, if you think about, you know, I always kind of use beer, the price of beer and food in the stadium, right? You typically use those goods at the same time, but maybe not everybody does. Well, what if there's a stadium where, you know, in order to attend that game, you have to park there, right? So really part of the price of attending the game is not only the ticket price, but also however much parking is, right? If I can get a, you know, ticket for $10, but parking around the stadium at minimum is $50, well, to attend that game, I'm gonna have to spend $60, right, in order to park my car and attend the game. So it's not just the price of the ticket that's influencing my demand. So we think about, you know, the ticket market and a complement being parking. If the price of parking goes up, am I more or less likely to purchase a ticket to that game? Less likely, right? If parking gets up to $1,000, I'm probably going to drive most people's demand down to zero, right? So increases in the price of the complementary good, right? So maybe think about it as if I've got, and I'll call this price of the complementary good goes up, and that's going to lead to it being overall more costly to kind of use both of those goods at the same time. And so we would see demand decreases, in whatever product we're looking at, right? So if the price of the complementary good goes up, we see a decrease in demand for whatever good we were looking at, right? So kind of the opposite of substitutes. And then the reverse would be true as well. If the price of complementary goods go down, then we see people being more likely to use that product or having a higher demand for that product, right? So the exact opposite would be true. Any questions on this one? Shouldn't be too bad yet, I don't think. Like I said, hopefully next week I'll have this thing working and I'll start to use a little bit more notation as opposed to kind of typing these words out. All right, so here's kind of a summary of some of the things that we just talked about, just kind of keep it all kind of in the same place. It has kind of normal and inferior goods, what happens when income falls or income rises, you know, what is going to cause a decrease in demand, and then the exact opposite, what causes the increase in demand. Well, it would be instead of income falling, income rising, right? And all, you know, et cetera, for all these other different changes. We talked about substitutes, complements. We didn't talk about expectations. I probably won't spend a lot of time on this because we won't do too much with expectations of prices and a lot of the topics that we discuss. I'll probably review a little bit more in supply because that's where we're going to see some things pop up throughout this semester. The other one I added in, or that's added on this list, is a good falls out of style. So this is just kind of a catch-all. There's like factors we can't account for sometimes that will kind of influence or increase or decrease the demand curve. One, I'll give an example. I guess it's sports related, but my brother is far down this path of like, I don't know, thinks he can make some money in the professional card industry, right? So baseball, basketball cards. So for whatever reason, there's been a really large spike in overall demand and largely hasn't been kind of explained. You can go out and do some Google searching, like there's some cards selling for outrageous amounts of money right now. For whatever reason, that market has seen an increase in demand, even for kind of like no-name players, right? So anytime we have one of these other things that we can't explain, this is kind of the catch-all category, right? It's, you know, there's just some fad or there's just some spike in demand that we can't explain using these other things. We didn't see any changes in substitutes or complementary goods. We didn't see income changes, you know, really that much. But there are kind of these fads or something that can drive demand as well. Okay? So we can think about those in a similar way. So supply shifters, you know, we thought, you know, one thing going into this discussion, remember, we talked about supply as representing marginal costs, right? So really that supply curve you could read as at each one of these quantities, this is the marginal cost of that quantity. So if we go back to, well, I got one right here. If we go to this original blue supply curve, at this quantity, the marginal cost can be interpreted as whatever point we'd be at on the y-axis, right? So supply kind of representing marginal cost, we can see things other than the price of that good that change. And if anything other than the price of that good changes, we might see shifts in that supply curve. So here, the very first one I have drawn out is here's our new supply curve, which is red. So we saw this kind of increase in supply, right? Or thinking about it differently, to provide the same quantity, right? So to provide the same quantity of this good, right, whatever that quantity would be, before, I would have only supplied that if the price were whatever this value would be on the y-axis. Now, in order to supply that same amount, right, you're going to have to pay me a slightly higher price, right? So that's one way of looking at this shift in supply, but that probably doesn't really hammer home why is it a supply decrease. So let's think about it going the other way. If I had the exact same price, right, so price doesn't change, okay? So before, at this price, we were willing to supply this quantity to the market. After we see a supply decrease at that same price, a supply decrease would mean that we supply less to the market, right? So remember, this red supply curve is the new supply curve. So before at this price, we would provide, say, 10 units. Now at that same price, we might only supply 8. And that would occur at any given price we look at. So we say that's kind of a decrease in supply, right? This kind of upward or leftward shift of the supply curve really is telling us that even if the price stayed the same, no matter what that price is, at every single price, we'd see a decrease in the quantity supply. Right? So that's why we think of this kind of leftward shift as a decrease in supply. The exact opposite is true with an increase in supply, right? At the same price, before, so blue being the original supply curve, we would have supplied this amount. At that same price, if we see an increase in supply, right, we're going to see that we supply a higher quantity, right? So this increase in supply is kind of like this push out or to the right, okay? Like I said, this is review. It might be kind of rudimentary, but we're just kind of making sure that we kind of have all this down, okay? All right, so let's clear all this. So what are some supply shifters? Like what causes these increases and decreases in supply? The very first one we'll talk about are input prices, right? If input prices go up, we're going to see changes in the supply curve. So think about it this way. If before, maybe before it was costing me $10 to produce the very first unit of a good. So to supply one quantity to the market at a price of $10, I was willing to do that because it cost me $10. So at a price of $10, I would supply that first unit to the market. Now let's say my input prices go up to $20. Well, now it's costing me $20 to make this product. The price is still 10. Instead of providing one to the market, I'm going to provide 0, right? So anytime we see input prices go up, we can think about this as a decrease in supply, right? Because, kind of intuitively, if it's costing me more to make that good, I'm likely going to supply less of it to the market. Or I might not even supply any of it to the market if that input price goes up enough, right? So we kind of think about there's two changes we could see. If input prices go up, we supply less, or a kind of decrease in supply. If input prices go down, well, now at the same price, I'm willing to supply more to the market, right? So we have kind of two types of changes we can see in input prices and their kind of corresponding effects. So one that is very closely tied to this is, let's say we see technology changes, right? So technology improvements, essentially, whether or not it's through labor or whether or not it's through like kind of your production process using machines, are going to make it such that I can provide the same quantity, but with this better technology, I can produce that same amount, but at a lower cost, right? So essentially, improvements in technology are decreasing my input prices, okay? So if I see an improvement in technology, I really can just say, okay, go back to what happens when I see a decrease in input prices. So improvements in technology, decrease my input prices, and will increase supply, right? I can now at the same price supply more to the market because with this new technology, I can produce it cheaper, okay? So what's some examples I have of this? This is kind of a cheesy one. I mean, we won't see input prices pop up too much in terms of products. We're talking about these sports-related examples, but I'll go through an example here in just a second that's a little bit different. You might not have seen in 201. I'm not sure exactly what your professors did, but this would be a general one you see. To make a baseball bat, right, you have to use lumber. If the price of lumber increases, what's going to happen to the overall the overall supply? Well, the price of lumber goes up, and it's one of the inputs to making these bats. Higher input prices means I supply less to the market, or there's a decrease in supply. Okay. What about a market that, like I said, you might not have looked at in 201? So for those of you who had 201, should have been all of you, but did you guys do a lot with the labor market? Not a ton, maybe just briefly touched on it a little bit. So the labor market is something that we're really going to focus on, and that's when we look at like player issues, right? We're going to look at like player salaries. We're going to think about the labor market, okay? So let me see. Oh, no, I just want to X, there we go. Just going to put a blank slide in here so we can kind of have something to work on. All right, so let's think about it. We've got this y-axis, got this x-axis. When it comes to the labor market, we can think about our y-axis usually as price. So what's the price of labor? Well, that's the wage that I have to pay them, right? When we look at general products, we look at the quantity of the product and the price. Well, now, if we're looking at labor, and we'll talk about what the quantity is of labor here in a second, the price of that labor is weight, right? Whatever wage I have to pay them. So down here on our x-axis, we'll just call this the quantity of labor, right? Or kind of Q subscript L, I'll typically write it as, okay? So we could have a supply curve for labor. If I can, there we go, right? So we can have this supply curve for labor. And if I think about things like, well, potentially, what if the league, right? And maybe I'm focused just on I'm just focused on players, maybe who aren't like superstars, but I'm just focused on kind of bench players or players I'm trying to use to fill the roster. So let's think about players I'm only paying kind of whatever that league's minimum is, right? Each league kind of has their minimum set out, right? Well, if I increase that league minimum that you have to pay a player, right, to fill out your roster or send your bench, well, really then to hire the same number of players, I'm now going to have to pay that higher kind of minimum wage or that higher kind of league minimum. So that would be an example where I see this input price actually increased, right? The cost of labor went up, right? Because of this league kind of minimum. And so I think about there, right? I'd have an increase in input prices, so I'd see a decrease in supply or the decrease in the supply of labor. All right, any questions on that before I keep moving? All right. And we'll do a lot more with the, where were we at? Here we go. We'll do a lot more with the labor market as we kind of continue. But really the main differences there is we're thinking about the price of labor is the wage, okay? All right, taxes are another one that very, very closely related to input prices, right? If you think about it this way, if I'm providing or if I'm producing something, and then all of a sudden you tell me, well, in order to sell it to your consumer, you also have to add this $2 tax to it, right? Well, essentially what I've done there is say, okay, or if I have to pay that tax to produce that unit, well, if my costs were previously $10, now they're 10 plus that additional $2 tax, right? So you can kind of think about taxes as an increase in input prices, which we just went through an example, increase in input prices, decrease our supply curve, right? So you can kind of think about, here's our original supply curve, which is blue, and the tax just shifts that supply curve backwards or decreases that supply curve by whatever the value of the tax was, right? So the difference between these two lines at any given quantity, the difference in my old supply curve and the supply curve plus the tax is going to be whatever the value of the tax is, okay? Is this looking familiar? Did you guys do some tax stuff in 201? Okay. But really it is just operating through like a change in input prices. That's really all a tax is. The number of sellers, we already mentioned if the number of buyers goes up, then at the same price, we just have more people who are willing to buy tickets. Same kind of idea. Even if the price is held constant, if we have more suppliers, right, or more kind of sellers of this good, at that same price, more people will want to produce it or want to sell it, right? So an increase in suppliers or sellers would also increase kind of our supply curve. That one is kind of intuitive, kind of makes sense there. You kind of think about it as, if we're thinking about the market for NFL tickets or NBA tickets, whatever league, even if all the prices were the same, 20 teams wouldn't be willing to supply as many tickets as if we had 30, right? Once we have 30 teams, we have a whole 10 more teams that are supplying tickets at that same price, okay? So this one gets a little bit weird. When we start to think about some of these products, we'll really have to think, I think I mentioned last class, how we define what we're looking at, right? So if I'm just thinking about, just the tickets to an NFL game, well, yeah, I might think about who are my sellers? What's an increase in my sellers? Well, that's more teams, right? But not necessarily, right? It kind of gets a little bit more fuzzy on what a seller actually means here. Because if we're thinking about just all the games, every NFL game in a whole season, I could actually keep the number of teams the same, but to get a higher number of sellers, I just have to create more days on which the product can be sold. So even if I have the same number of teams, if I increase the number of games each team plays, well, that's an increase in the number of sellers. Which is kind of weird to think about because it's the same number of teams. It's just they now have more days on which they can sell this product, right? So the increase in the number of sellers gets a little bit weird in some of these examples where we typically would think about teams are the only way, an increase in the number of teams is the only way we could see an increase in the number of sellers. But actually we could hold the number of teams constant and just have more games in the season to be able to sell this product, okay? So it gets a little bit tricky there. And kind of, you can think about, if we had more teams or the higher number of games, it's really maybe think about the total number of games that are being supplied. And the total number of games is going to be, a function of how many teams there are and how long the season is. Okay? So the next thing we'll talk about, the supply curve is expectations, because we see a little bit more influence in these sports markets based off of expectations. So let's say, we think about some things that typically wouldn't be related to a lot of products, right? So if we think that a game is more likely to be a very cold game, maybe let's not think about a huge sports market where they might sell out anyways. Let's think about maybe some of these smaller colleges, right? If it's supposed to be snowy and 20 degrees, they're probably not going to be able to sell as many tickets, right? So expectations about not just the price, which is probably things you've talked about in previous econ courses, but expectations on conditions of the game, or just thinking about not just weather, but you could think about expectations of other things that might be occurring in that city, right? That might prevent people from being more likely to attend the game. We'll start to see a lot of these factors play a role as well. Winter probably being kind of the main one when it comes to kind of thinking about ticket prices and things like that. What was the other one I was thinking? Oh, and a lot of what we'll kind of enter the discussion at times is the expectations just of, what they think people are doing on certain days. So if I schedule a game, I think the example I have here is, I think possibly that people aren't as likely to maybe watch a sporting event on New Year's Eve as they might be the following day, right? People might be more likely to be out and about on New Year's Eve as opposed to New Year's Day. I might think they're more likely to be home and then in turn more likely to watch the game. Then when it comes to scheduling my games, I want to schedule when demand is going to be the highest, right? So based off those expectations, I'm going to try to schedule games where I think that demand could be at its highest based on my expectations of just basically people's behaviors, right? Or their kind of movements based off of whatever the day is, factoring in holidays and things like that. One thing you might have already talked about in other courses are price expectations. So the idea here is if I expect, how did I start out? Yeah. So an increase in the expected price. So if I think that tickets to a game are going to continually increase, so I think that by next week, ticket prices are going to be $50 higher. What would I be more likely to do if I'm interested in attending that game? Buy the ticket today or wait and buy it next week? It's not a trick question. If I think the price is going to be higher, $50 higher a week from today, what am I going to do? Buy my ticket today, right? So if we expect higher future prices, I'm more likely to buy that product today. So higher expected future prices actually increase kind of current demand. Oh, sorry, we're talking about supply. So yeah, so I explained it through demand. So higher expectation of prices could increase demand, but if I'm selling the product, right, and I think that the price is going to be $50 higher next week, if I'm selling the product, am I more likely to want to try to sell that ticket today or hold off and sell it next week? Hold on, right? So it works the exact opposite for our sellers, okay? So higher expected prices in the future means that demand could potentially increase today, but higher expected prices in the future would cause current supply to actually decrease, right? People are going to hold on to those tickets and try to sell them next week, okay? It's really basically, this is like kind of fundamentals of the stock market as well, right? If you think that prices of your stock are going to be higher next week, you'd be less likely to sell today or supply kind of that stock to the market today, more likely to hold on to it and try to sell it next week, okay? And then the exact opposite, if we expect prices to be lower in the future, right? If I'm a seller, then I want to try to sell everything today if I think I can only get half as much a week from today for it, okay? So I think I had a summary. So those are kind of all of our supply shifts. And I'll work through a couple examples and kind of mention some things with these graphs that I want to make sure that we keep in mind. So let's say we've got what? The supply curve for stadium beer. One of the major inputs, hops, the price, I'm saying, increases. So if the price of hops increases and it's a major input, what's going to happen to our supply curve? So before we even think about visually the shifts, if my input prices are higher, I'm going to supply less, right? A decrease in supply. So decreases in supply, you can kind of memorize it as it's a shift kind of to the left and up, right? So our decrease in supply is kind of a shift to the left and up. Now, why is that? It's because at the same price, I'm now willing to supply a smaller quantity, right? And so we'll kind of see B, or this decrease in supply, would exist from this effect. Okay? What if I see this price of stadium hot dogs increases? What happens to the supply curve for stadium hot dogs? Which of these? C, right? So I see a change in the price of that good. That means, just like with demand, that doesn't mean that I'm going to see a shift in that curve. It means I'm moving along that curve, right? All I've done is say, okay, the price for hot dogs went from P1 to P2. What's the new quantity supply going to be? Right? So I'm just shifting along that supply curve. Okay. So we've talked about supply, talked about demand, we've talked about kind of the shifters. We also have this thing, which I even alluded to last class, which is equilibrium, right? So if I transposed, here, let's skip ahead. If I transpose kind of on the same graph, put my demand curve here and my supply curve here and my demand curve here. So do I have labels? No. So my supply curve being the blue line, my orange line being kind of my demand curve. Wherever those 2 points cross, that's what we'll call equilibrium. Right? So why is that the case? Well, if we think about if any other price existed, right? So let's say the price was $16. The price is $16, right? There's people that, there are a few people that would demand to purchase that product, but not a lot, right? Now, if we look at the supplier here at a price of $16, they would be willing to supply a whole bunch more tickets, right? Because they're selling it, so they like it that this price is high. Well, we kind of think about that as we've got a huge supply at $16, but a relatively low demand. We have a huge surplus, right? We've got way more than people want to buy, okay? So if that's the case, right, the sellers are looking at this and say, okay, well, I'm not selling very many tickets. I would be willing to, but there's no one willing to buy them at that price. So I'm going to decrease the price maybe to $14. At $14, I'd still be willing to supply quite a few, but not quite as many as I was before. But at that $14 price, there's still not very many people that are demanding that product, right? So I'm still only selling what looks like about 3 here. So this process continues, right? I lower the price a little bit more, right? I continue to lower the price a little bit more up until the point where now the amount that I'm willing to supply, I can find a buyer, right? Or that quantity is demanded by however many people are out there kind of thinking about purchasing the product, right? So once we get to this point where quantity demanded is exactly equal to quantity supplied, we call that the equilibrium, because at that point, I don't have any incentive to increase the price, because if I do, I'm just going to sell fewer of that good. I have no desire to lower the price, because if I lower the price, I'm not willing to supply as many, and so therefore, there's less for me to sell. And so once we get to that equilibrium point, we shouldn't see any kind of movement by the supplier in terms of how much they're producing or kind of what price that they would charge for that product. Okay? Any questions on this? Okay with this? All right. I kind of already mentioned this, but if the price was too high, we would see that the quantity supplied is higher than the quantity demanded. This is kind of a nice little visual of it, which would mean we have a surplus. And the way that we would kind of define this surplus is how much higher is quantity supplied than quantity demanded. So here we would say we have a surplus of 3 tickets, right? We have 3 tickets that we'd be willing to supply, but there's no one out there demanding to buy them, okay? So I should have started this out. We're looking at $12 here, right? That's all that was. So what if it was $6? Kind of already mentioned something along these lines as well. I didn't necessarily give it a name, but at $6, my quantity supplied is much lower than my quantity demanded. So there's way higher demand than there is available product. We'd say we have a shortage there, right? And the amount of the shortage is just the difference between the two. Okay? Shouldn't be anything too tough. So we can now start to think about, we know how to identify this equilibrium point. We know that there's things that shift the supply and demand curve. So how will those shifts in supply and demand impact the equilibrium price, right? Oops. So this shouldn't be too bad. Once again, I'm going to have to use this annotation skill. So if you have any questions, make sure you speak up, bear with me, because I don't like using it as much. So let's say we've got this market. We've got, what I have, annual income. So I'll draw my demand equation. Here's my supply. So let's kind of label these. So supply. And kind of our original demand curve, right? So we can kind of see before, right, we have this equilibrium point where supply is equal to demand, right? So we'll kind of call this P1. So this is our original equilibrium price. And down here, we'll call this Q1, which was our original equilibrium quantity, right? So what happens if we're looking at the NFL jersey market and annual income in the US falls, right? So we see a decrease in overall income across the country. What would happen to my demand curve there? Less money, people are willing to buy less of it, so we see this decrease in demand, right? So this decrease in demand curve will kind of shift closer to that origin point. So we could think about, I'll try to draw it kind of extreme here so it's easier for me to label. So we could call this, I don't know, let's call this the new demand curve. Whoops, if I can click on it. Oh, I know what I have. Hold on. Delete this. Well, you can see it. It's the new demand curve there, right? So with that new demand curve, our equilibrium is now going to be where that new demand curve, right, intersects the supply curve. So it's going to be over here. Right. So now we can kind of think about our new equilibrium price. We'll call that P2. It's going to be somewhere over here. And our new equilibrium quantity, we'll call that Q2, is going to be over here. So once we plot those points, we can very clearly see, you know, thinking about it, one being where we started, two where we're at after the change. Prices go down and quantities go down, right? Quantities sold go down and then kind of the price goes down there. So no matter what shift we have, we can draw the shift on our graph, identify the new equilibrium point, and then determine whether or not equilibrium prices and quantities have increased, decreased, or you know, worked in opposite directions. And there'll be, you know, a different, you know, combination of those changes as well, right? So here we just have the effect of a demand decrease, right? So what if, so has everyone got that down? Can I get rid of that? Okay. So the next thing we'll think about is, what if there is a technology improvement in the production process for these jerseys? And I even kind of gave you, remember, technology improvements decrease our input prices, okay? So now we're thinking about what that looks like. All right, so here we've got quantity, price. Let's call this my original demand curve. Here's my original supply curve. And then how can I? So we start out here, we see a technology improvement, input prices go down, which means what happens to the supply curve? Goes up, or it increases, right? Now this is where I have to be a little bit careful, because I say it goes up, but when supply increases, that actually means at the same price, I'm willing to supply more. So the supply increase is actually like a shift to the right, right? Because that really depicts at every given price, I'm willing to supply more to the market. If the price is here, supply more to the market. If the price is up here, supply more to the market, so on and so forth. Okay? So what's happened? So my old equilibrium point, which I probably should have drawn first, was over here, right? So we'll call this, oh man, this is terrible, P1 and Q1. Okay? My new equilibrium point is where that new supply curve intersects demand, or somewhere out here. So here, my new quantity, my new equilibrium quantity is higher, but my equilibrium price is lower, right? So we can do this for any change that we would see in supply and demand. In fact, the first homework will probably have some questions where I give you something occurring, like a technology improvement, and then expect you to know that means you'll see a supply increase, draw the supply increase to determine what happens, where's your new equilibrium price and quantity relative to where it was at before, okay? Should be a review there. Everyone okay with this? Got this written down? Okay. So what if we have those two changes occur simultaneously, right? So the first one we had, I believe, was a demand decrease, and the second thing we had was a supply increase, right? Well, it gets a little tricky when we have something like that. So go through here. Let's just go to change the black. So we've got our original demand, our original supply curve. Here was our old kind of equilibrium point. Okay. So call this P1. And we had down here Q1. Okay. We just said what happens if there is a, what was it, demand decrease, and what happens if there is a supply increase. So I'm going to draw this in such a way that kind of highlights the issue when we have simultaneous changes. Okay, so there's my new supply curve. Here's my new demand curve. I'm just kind of using a little like slash apostrophe to kind of identify that's the new supply and new demand curve. Okay? Based off of how I drew this, where's my new equilibrium point? Well, it's where the new supply curve intersects the new demand curve. So actually, it looks like from those changes, the price has went down, but quantity actually stayed the same, right? So that's just because I drew it that way. If I had drawn a much larger increase in supply, so let's say supply increased all the way to out here, well, now the new equilibrium, it looks like the price is lower still, but the quantity is now higher, right? But if I had drawn like a really, really small change in supply, well, now prices are lower, but quantity would also be lower. So it really depends on what the relative size of those shifts are, right? Now, it's really hard to get at that a lot of times, unless you have the actual equations for your supply and demand curve, and you know exactly how much they've shifted. So when it comes to like questions I'll ask you on the exam or like in the homeworks, unless I tell you that one of the supply or the demand shifts was larger than the other, really the answer is, you know that price is going to go down, but you don't know about quantity. Quantity could actually stay the same if those shifts were exactly the same, right? So the way that I always kind of tell people, I think the best way to kind of break these down when you have simultaneous changes, let's think about just actually let's see if I can undo and go back to where I only have there we go. So let's say we had just that supply increase and demand decrease. What I would suggest doing, instead of drawing it out helps a lot when you have one change. When you have simultaneous changes, I always say, this is how I approach it, right? What if I had only had that demand decrease, right? So the demand decrease, we drew it out earlier. We said what happens if it's just the demand decrease. My new equilibrium would be here, which is a lower price and a lower quantity. So this demand decrease kind of led to price, and this should be a D. So if you can't quite see that, that should be a D. So led to a price decrease, but also a quantity decrease. Right? What about my supply chain, right? My supply change was that supply went up. So a supply increase here led to what? Well, if I just had the supply increase, my new equilibrium point would be where supply is equal to the old demand curve, which is a lower price than before, but a higher quantity, right? It's higher than Q1. So there, that change would decrease the price, but it actually, if we only had that change, it would increase quantity. So if we have these two things happening at the same time, we can see they're both pushing price down. So if both of them occur and they're both pushing prices down, we know the new equilibrium price has to be lower. However, because they're pushing quantities in opposite directions, if these changes both occur at the same time, we don't know what's going to happen to quantity unless we have an idea about the relative size of those shifts. Okay? Is everybody, any questions on that? We're okay with this? And you know, I just walked through one combination, right? There are, you know, we can think about, we have demand and supply increases, demand and supply decreases, or kind of the different combinations. And so I have a little bit of a summary that if you're still kind of wanting a little bit more review, I would suggest kind of going over these a little more in detail, but they kind of just show what would happen for the different combinations of those things. So demand and increase, supply decrease, demand decrease, supply increase, excuse me. And then kind of if they both increase, both decrease, right? I also put up kind of if I'm doing this by shorthand. So when I suggested if we have two changes occurring at the same time, identify what a demand increase would do to equilibrium prices, identify what a supply increase would do, and then the total effect would be kind of using both of those, right? So you can kind of notice for a supply and a demand increase, the supply and demand increase would both push quantities up, but they push prices in opposite directions. So if this occurs, we know quantity is going to go up, but we don't know what's going to happen to price because those two effects push prices in the opposite direction. You can kind of walk through the different combinations as well. Okay? But like I said, I always kind of suggest doing this shorthand to kind of break down the individual effects of each shift, and then we can kind of see what the total effect is by combining the two. Okay? Any questions on this? And you can draw it out. It's just the problem is, like when I drew it out, I showed you, depends on how large you draw those shifts, right? And so doing it this way, I think, kind of prevents us from making those mistakes where we say, well, yeah, quantity definitely went up. Well, no, it only went up because you drew the supply shift so hard, you know, so much larger, right? And if you weren't told that, then you don't really know. You don't really know if that shift was larger than the demand shift. And when just kind of notation, when I put here these double arrows, that kind of means indeterminate, right? We're not sure which way it's going to move. Okay, it could be either direction. Okay with that? Okay, I see a lot of nodding heads. Where are we at in time? Oh, okay. This is just kind of an example. Might be something that I would try to put in on an online quiz. Although today's online quiz that I'll post when I get back to my office will just be, I think I mentioned last class, asking you, are you a freshman, junior, senior? What's your highest math class? A couple questions like that. Make sure when we get on and get that done, that'll be due before we meet in class on Tuesday, right? I would say just get it done today. It's not great, you know, today's isn't even graded for correctness. You just have to go on, answer a few questions about yourself and get the easy first 10 points, okay? So here's just an example, you know, where we have kind of one shift. So let's say, what happens if income across the country increases? We kind of already did one like this. If income increases, what happens to demand? People are more likely to buy the product, so we see a demand increase, right? So a demand increase is a shift to the right, so we've got A there, right? A shift to the right in demand. Should be pretty easy. What if we see two new expansion teams? So actually, this is something that throughout the semester we might play around with a little bit more. I always like to use like relevant examples that are occurring, and we haven't had this for a while. But the NBA is actually right now thinking about potentially adding some expansion teams, right? Entering into some new cities. So if we think about there being two new expansion teams, what's that going to impact? Supply, right? We have more teams, we have more games that are going to be able to be played, right? So if we have more games that are able to be played at the same price, we'll think about supply is increasing. So a shift in the supply curve, so it's going to be between C and D. And if it's a supply increase, that means at the same price, I would supply more. So this is going to be the guy we're thinking about, right? This rightward, outward shift, or this increase in supply, okay? What if we have both of those things occurring? So two new expansion teams and higher incomes. Well, that was a demand increase and a supply increase. So we can kind of think about there. Demand increases and supply increases will be kind of over in this area over here, which really, depending on the size of the effects, any of the points in this shaded area could be our new equilibrium, right? Now you'll notice all the points in that shaded area, we would see a higher quantity, but the price could be lower, could be higher, or it could be still the same as it was before if those two shifts were exactly the same. Okay. Any questions over any of those? If you have them, don't feel like you can't ask. I want to make sure we have a good understanding of kind of the base of things here. Okay with that? All right. So I think I'll save this for next class. We'll do a little bit more before we get out of here, but we'll kind of pick up next class talking about ticket markets, how they look a little bit different than our original supply and demand curves, right? So we're going to be throwing kind of a little bit of a wrinkle into things that you've probably seen before. I'm guessing this will be the first thing that's completely new. But before we do that, I do want to do a brief review of kind of linear regression, okay? We'll definitely spend more time in this every single week. But I talked about with your projects and then these papers that we're going to be going through every week, we want to think about how we can use regression results to understand the relationship between two variables. So really what we're trying to do with regression is say, look, I have this variable y, and it's a function of, right, this is just a constant, but it's a function of this other variable x, right? So as x goes up, y will change by whatever this value b is, right? If x goes up by 1 unit, then the new y value would be calculating is 1 more unit higher, so it would be b amount higher, right? This value b tells us the slope between x and y, or 1 unit increases in x would cause y to change by whatever this value b is, right? So right now I'm just using letters because we don't have actual numbers. But what we do with the regression equation is we use some data, right? Use this tool of linear regression, which I might dive a little bit more into the theory kind of next Thursday. But all we need to know is we can interpret an estimate that we can get from Excel for the slope coefficient as the change in our y variable from a 1 unit increase in our x variable. All right, so that's always kind of our general interpretation of that value for b. Now, some other terms I'll use, so I'm calling them y and x for right now. That y variable, or that variable on the left-hand side, is the variable we think depends on that x variable, right? Y is being influenced by changes in x, so we call that y variable our dependent variable. And then x is the thing that's changing, so it's independent of y, right? X is changing and then causing changes to y. So we call x our independent variable. And then regression analysis is really just how we can understand what the exact relationship is between that x and y variable. As that x variable goes up by 1 unit, how much does our the value of our y variable change, okay? So we can kind of think about it as we had a bunch of data and we just created a scatter plot. If we draw a line of best fit through that data, that line is going to have an intercept value a, right? And then the slope of that line will be the value for b. Right? So anytime we see a 1 unit increase in x, how much y changes is however much y falls in this example, right? Because we have kind of a downward sloping line, right? So here we would think the value of b is going to be less than what value? We have a downward sloping line, b is negative, right? Less than 0. If we had an upward sloping line, the value for b would be positive, right? So we've got our intercept, we've got our slope. We can think about, there are many different relationships. Here I mentioned this one, a positive relationship where the value of b would be greater than 0. What if we had one that looked like this? The value of b here is exactly 0 the way I have it drawn up here, right? It's a flat line, okay? So this would say that it doesn't matter if we see changes in x because y doesn't really change much regardless. Right? We'll kind of keep everything linear. Maybe halfway through the semester, we'll start to think about how we can include quadratic terms. I won't go too detailed to them, but we'll keep things linear for right now. Okay? So what might this look like for an example that we'll use? So we might think about something like the salary of a player is likely influenced by how many points they score in a game. So you could use basketball, but you could translate this to whatever sport you're interested in, right? So we can run this linear regression in Excel, and if we have data on different players, the points they scored every season and what their salary was, we could actually understand that if I scored, 1 more point a season, what's the impact that would have on my salary, right? That's what that slope coefficient tells us. A 1 unit change in that x variable causes the y variable to go up or down by whatever this b value is, or here I'm calling it kind of beta 1. We'll see that a lot in these academic papers. Instead of a and b, they'll kind of use b subscript 0 as the intercept and b subscript 1 as that kind of slope coefficient. Okay. So I kind of mentioned here, and I already mentioned, we can find these using Excel, and then once we do, we can kind of interpret them. Okay? So I won't waste too much time on this because I also just want to briefly, because I said, you know, if you can kind of look through it, that'd be great. We'll talk about it a little bit. This is a really short paper. We'll kind of see what they did with some linear regression here. So the main idea of this paper, you didn't even have to read the abstract or intro probably. It's kind of in the title, right? So it is, you know, we have all these colleges who have started to make beer available at their games. What's happened to their attendance, right? So is kind of allowing beer to be sold at a game, is it increasing attendance? Is attendance not really changing? Or is attendance decreasing? I'm not sure. You know, you could tell a story maybe. Families, you know, think it's a less family-friendly environment, so they don't go. I remember as a kid going to Purdue games, and like there used to be this frat right on the main road up to the stadium, and I remember walking by at like age 8 or 9 and just seeing like what you would imagine every movie would depict a fraternity like. So, you know, maybe there's some decreases potentially. So what they did was they thought about this as, okay, we've got this question, is making beer available increase or decreasing attendance at these games? So we'll go down here to the results, and I'll annotate this. So basically what they were saying was, well, look, the variable that we're interested in is attendance, right? So that's our y variable. And we know that there's some intercept value a and some slope b, and we think this attendance variable depends on whether or not this variable x, which just is a 1 if the stadium allowed beer sales and a 0 if not, okay? So now we can interpret this slope coefficient, whatever the value for b ends up being, this is how much attendance would change if the stadium had beer sales available, right? Now this is a very simple linear regression, and it will come up with some really wild results if we don't control for a lot of other factors, right? If we just think about, is beer available at the stadium? Well, that's not factoring in how good is the team. Is this in a really large school? Is it in a major conference? Is it, you know, a nice day, right? Sunny instead of cold and snowy. And so they tried to include a bunch of other, essentially, you just start including additional variables into that regression, okay? And like I said, we'll review a little bit more linear regression and how we're getting the results, but just kind of setting this up as a first look. So we can really think about it as we're controlling for all the other things we can add into this regression. So they add in all these variables, right? Like win percentages, population, undergraduate enrollment, whether or not they're in certain conferences, and don't have to worry too much about kind of what's going on in these different columns. Just know that this last column is the one where they were able to control for as much as they could, right? As many other things as possible. And what they found was if this beer variable, right, this was just a 0 if it was available, 0 if it wasn't available, 1 if it was. So a 1 unit change there is just going from a school that didn't allow beer sales to a school that allowed them, right? So the change in attendance from beer sales is about 1,800 additional people, right? Which might not be huge for schools like Ohio State. When you're talking about schools, and they mainly, I think you can see here, we're focusing on smaller schools like the WAC and the MAC. So that's a pretty sizable increase in attendance, right? Holding everything else constant. So when we include these other variables, what we're really saying is 2 teams with the same win percentage had the same win percentage the year before, same population of the city, same undergraduate enrollment. They're both in the WAC. They both have the same stadium capacity, holding all the other things else constant, but one of them makes beer sales available. We would expect their attendance goes up by 1,800. Okay? So this is kind of our first look at how we work through look at these papers, think about these regression equations. We'll spend a lot more time on regression next Thursday. I just want to kind of give a little bit of an introduction. This is a real easy first paper because it's pretty short. They really only had one regression that they had to provide results for. But that's a little bit of a taste into kind of what we'll be doing with these readings. As we work through more material, it'll be a little bit easier to understand. As we go through more regression examples, it'll be a little bit more easy to kind of evaluate or interpret these, okay? So what do you guys need to do before Tuesday? Get that online quiz done. Just get on, answer those few questions. I'll put up the lecture slides Sunday night for the next week. And then probably by the end of next week, I'll put the first homework up there. It'll have like a 3-week time period because we still have to cover a lot of stuff. But you can at least start to get a little bit of work on it at the early problems of it. Other than that, if you have any questions about anything, feel free to reach out, send me an email. And hopefully I'll have this working on Tuesday, and I'll see you guys then, okay? Have a good, safe weekend.